Hi, and welcome to Mr. Garofalo's podcast. In today's episode, we are looking at solving compound inequalities. Well, today we'll take a look at a couple of homework problems. Let's start with the number 3, which is a compound inequality joined by the word and. So remember from class that when we have a compound inequality connected using the word and, that both statements must be true in order for the entire statement to be true. So in other words, when we get to the end of this problem, our solution set must have values that when replacing x in this inequality and in this inequality make both of them true at the same time. So let's find out if we can accomplish that. So the solving here, not too strenuous, right? 8 minus 6 would be 2. So we would have a solution set of x is less than 2 and add 1 to both sides here. We would get x is greater than 2. So we have x is less than 2 and x is greater than 2. Now we think about that on a number line. We can clearly see that this solution set does not include 2. And this solution set does not include 2. So there definitely would be an open circle on 2. But let's think a little harder about what this is saying. In order for this first inequality to be true, x must be less than 2. So that would be these numbers, right? And then for this inequality to be true, x must be greater than 2, and that would be these numbers here. Well, let's think about that. There's no overlapping of the shading, right? So how could a number be less than 2 and greater than 2 at the same time? It's not possible. Well, if we chose some numbers here, say 0, right? 0 plus 6 is less than 8. That would be true. However, 0 minus 1 would be negative 1, which is not greater than 1. So values from this solution set don't make both of them true. What about if we try to value from this solution set, say 4? Well, 4 plus 6 is 10. 10 is not less than 8. So once one of these is false, then the entire statement would be false. So there's actually no solutions to this. It's not possible for x to be less than 2 and greater than 2 at the same time. Let's take a look at some others. How about number 9? Negative 2x is less than 6, or x minus 2 is less than 2. Okay, so we'll solve each one of these individually. Now I'm going to make a move here that is going to have an impact on our solution set, right? I'm going to divide by negative 2, which is great for getting x to have a coefficient of 1. But remember, if we don't reverse the symbol here, we're going to get solutions that make the inequality false. So this must become greater than negative 3. Or we add 2 both sides. This one, we get x is less than 4. So x must be greater than negative 3. So it wouldn't include negative 3. And all the numbers that are greater than negative 3 be this direction. Or x could be less than 4. Okay, so don't include 4. But if you look there, it's actually 4 is already included in the other solution set. And remember, only one of them needs to be true. So actually, even though it's an open circle, 4 is actually going to be included in our solution set. And then less than 4 would be this direction, right, to the left. Now, we saw this, we discussed this in class. You had a homework problem like this a little bit last night. It was number 6. And we discussed it at the beginning of class today. And the fact that we have overlapping shading, right? This black shading and the red shading are overlapping. And the question became, should we kind of bring this shading back so that they don't go past those boundaries, right? Should it just be the numbers in between negative 3 and positive 4? Well, when in doubt, we can always test, right? That's one of the nice things about equations and inequalities. You can always choose values of x and see if the expressions come out true or not. So let's say we picked -5 and we plugged it in. -2 times -5 is less than 6. We get 10, excuse me, -2 times -5 is less than 6. We would get 10 is less than 6, which is false. So it's not looking good here for -5, right? But let's try it in the other inequality. -5 minus 2 is less than 2. That would be -7 is less than 2. Well, that's true. And the statement is connected by or. Only one of them needs to be true. So guess what that means? That shading should continue past -3. In fact, all these negative numbers in this direction will give us at least one statement that is true. Now let's wipe away this text, and let's try some numbers that are beyond +4. Let's say we did -5, so let's do 7. Okay, so the first inequality would be -2 times 7 is less than 6. This would be -14 is less than 6. Now look at that. It's true. We didn't even need to bother with the other one. Once one of the statements is true, because they're connected by or, the entire statement is true. So we should actually take that shading and bring it all the way back through. See if I can grab that black shading there. There it is. And bring it all the way back through. Now, it doesn't have to be two colors. Ultimately, what's happening here is that it's all just one shading. Okay, I'm actually going to put this red on top. It's actually all these numbers. So all real numbers would be solutions here. All real numbers. All right, well, hopefully this was helpful, and I'll see you in class tomorrow.